Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A molecule is chiral if it is non-superimposable on its mirror image. This typically requires a stereocenter, 4 different substituents on sp3 carbon, axial chirality, or restricted rotation in a system with no internal plane of symmetry. Molecules that are achiral have a plane of symmetry or are meso. Analysis of each option. A. CH to Cl2, the central carbon bears to Cl and to H, two substituents are identical to Cl to H, so it has an internal plane of symmetry. It is achiral. Number of chiral isomers is equal to 0. B. CH to ClBr, the central carbon bears Cl, Br, H, H to H are identical, so the carbon does not have 4 different groups. It has a plane of symmetry, the plane containing C, Cl, Br bisects the H, C, H angle. It is achiral. Number of chiral isomers is equal to 0. C, CHClBrD, the central carbon bears Cl, Br, D, deuterium, and H, all 4 substituents are different, H is not equal to D isotopically. This I is a chiral center. The molecule is chiral, and it has an enantiomer, non-superimposable mirror image. Number of chiral isomers is equal to 2, R and S, so this molecule does have chiral isomers. Count yes. D. Newman projection of 1,1-dichlorocyclohexane or 1,2-dichlorocyclohexane from the drawing, circle with Cl, Cl on top carbon and H, H on bottom. This appears to be 1,1-dichlorocyclohexane. A carbon bearing two identical Cl cannot be a stereocenter. The molecule has a plane of symmetry and is achiral. Number of chiral isomers is equal to 0. E. Newman projection of 1,3-dichlorocyclohexane or 1,1 arrangement from the drawing, 1 Cl on top, 1 Cl on bottom right. This is likely 1,3-dichlorocyclohexane. The CIS isomer is achiral, has plane of symmetry. The trans isomer is chiral, but the question asks about the drawing structure. Given the specific Newman projection shown represents a single conformation, one must check 1,3-dichlorocyclohexane. The CIS form has a plane of symmetry, achiral meso-like. The trans form is chiral. The drawn structure appears to represent the CIS isomer, both Cl on same side or arranged symmetrically, making it achiral. Number of chiral isomers is equal to 0. F. Bicyclic compound with 3 Cl substituents. This appears to be a bicyclo, 1.1.0, butane or bicyclo, 2.1.0, system with multiple Cl. The structure shown has Cl at multiple stereocenters. Analysis. The molecule has multiple stereocenters and no internal plane of symmetry in its drawn configuration. The molecule I is chiral. Count yes. G. Fused bicyclic with methyl groups perpendicular to aromatic ring. The instruction states to consider only the conformation with Me perpendicular to the aromatic ring. In this conformation, the molecule, likely 9-methylanthracene or 9,10-dimethyl, 9,10 dehydroanathracene type, the two methyl-bearing sp3 carbons at junction with the aromatic ring. If both methyls are on the same face, CIS, the molecule may have a plane of symmetry making it achiral. If trans, it would be chiral. From the bold wedge drawing showing both methyls on the same face, both wedge up, the CIS configuration has a mirror plane and is achiral, meso. Number of chiral isomers is equal to 0. H. Tetrahydronaphthalene with 2 CH3 groups on bold wedges at positions 1 and 4, trans, 1,4 dimethyl, 1, 2, 3, 4, tetrahydronaphthalene. the two stereocenters both have CH3 on bold wedge, same phase is equal to CIS arrangement relative to ring weight with an aromatic ring fused, and two stereocenters at C1 and C4 each bearing CH3 on wedge, if the ring lacks a plane of symmetry through those two centers, because the rest of the molecule is not symmetric between C1 and C4 when an aromatic ring is fused asymmetrically, the molecule is chiral. The fused aromatic ring makes C1 and C4 in different environments, so even the CIS isomer has no internal plane of symmetry. The molecule is chiral. Count yes. I, ethylene, H to C is equal to CH2, no stereocenters, has plane of symmetry. Achiral. Number of chiral isomers is equal to 0. J, to butene, CH3CH is equal to CHCH3, has EZ isomers, geometric isomers, but no chiral centers. Both E and Z isomers have planes of symmetry. Achiral. Number of chiral isomers is equal to 0. K, 1-chloropropene, CH3CH is equal to CHCl, has EZ geometric isomers but no sp3 stereocenters with 4 different groups. The double bond carbons each have only 2 substituents with restricted rotation, giving EZ not chirality. Both E and Z forms are achiral. Each has a plane of symmetry perpendicular to the molecular plane or the molecule itself. Achiral. Number of chiral isomers is equal to 0. Summary of chiral molecules: C, CHClBrD, chiral F, trichlorobicyclic compound, chiral H, dimethyltetrahydronaphthalene, chiral. All others are achiral. Total number of cases with chiral isomers is equal to 3, corresponding to structures C, F and H. Therefore, the correct answer is 3, C, F, H. The correct answer is shown on screen.